Hello and welcome to my presentation. I want to present today something about our ambition to make the piling operation to install the foundation offshore more sustainable. My name is Nils Raab. I'm sales manager at Mink, responsible for the renewables sector, as well I'm a business development manager for our holding group, the Acteon company. I have almost 15 years experience in offshore wind and am responsible within Ming for the constant improvement of our product to adjust them to the ever increasing requirements for the offshore wind market. I'm based in Germany and are constantly traveling to support the growth of the offshore wind market, obviously in Europe, US, and Asia. To me personally, I'm 45 years old and I'm holding a diploma degree of the Technical University of Lübeck. Before we go into the details of our hammer, I would like to share some words regarding Acteon. Acteon is our holding company. We are a company which have almost 2,000 employees, and we are working or defining ourselves in being responsible and working in the complete offshore arena. Offshore arena means for us everything from nearshore construction, oil and gas, as well as renewables. With those kind of capabilities, we especially now focusing on the renewable markets, installed over 2,500 foundations for wind turbines. To cluster that a little bit more, the offshore arena is our area where we provide our services, and we're not limited to any special area. We provide services in the pre-development, especially like geotechnical investigation. We support clients in pre-feed study during the development, and obviously the operations area where we belong to for the installation of those foundations. We support and have services for the life cycle of the wind turbine, and at the end we provide services for the decommissioning and support of the same. Now concentrating a little bit more on the topic of today, sustainability. That I would like to take you a little bit along. This is our current portfolio. We provide hydraulic hammers from the size from 100 kilojoule all the way up to 4,400 kilojoule on the right hand side. This is currently at the moment our largest monopile hammer, which is at the moment working, for example, in the Dogger Bank field of the United Kingdom. Along going with our hammer, we provide the services, so we maintain, operate the equipment and support our clients in the piling activities. So when we're talking about sustainability, we need to go a little bit into the background and in the fundamentals of Mink. What is Mink? Mink is a company which is founded more than 150 years ago, and in focus was always the pile driving. And the pile driving is a technology which have been used for decades. And with that usage and the track record we gained over the 150 years, we have developed ourselves as specialists for pile driving. The challenge we have nowadays is that especially the renewable arena goes along with new requirements in the area of sustainability, which for a very good reason challenge the traditional technology which has been used for 150 years in a way to protect the environment. And this is the challenge for us, that we need to, on the one side, stick with the technology which has been proven over decades, as well as being the most sufficient pile driving technologies for several soil conditions, and on the other side, to optimize the pile driving in the way that we continue improving the environmental protection result. We identified 3 areas whereby I will, due to the time limitation, concentrate on the noise reduction as well as the cooperation. We are doing at the moment in the market, especially the noise reduction is for us a really important topic, the underwater noise reduction in specific, because the underwater noise reduction, which is treated from our side as a primary noise reduction, is the most crucial element for piling activities. We have two countries, Germany and Taiwan, which have at the moment the most strictest underwater noise limitations, and hence the impact hammer to install the pile is somehow the reason why the underwater noise is transmitted into the water, because the impact is necessary to overcome the soil stress and to get the pile moving and penetrating. This shock impact given from the hammer is necessary to overcome the soil stress on the one side, but on the other side, this peak value in force stands for the underwater noise emission, or a peak in force stands for a peak in underwater noise. So the challenge on our side was actually to change the original traditional technology and to go into the fundamental characteristic of that hammer and to change the force character. And what we have done, we developed a system which is integrated into the original hammer and transfer the forces over those 6 lenses you can see on the left hand side. So the ram weight is giving the energy into the first lens and all the way long into the anvil from which the force is given into the pile. The energy is transferred via those 6 lenses. Those lenses are made out of the same steel as the ram weight is, and but they change the force character in the way that we do reduce the peak of the force and transfer the force over a longer period of time into the monopile or into the jacket pile. This change of force character has a positive impact on the underwater noise. The system itself is, I mentioned that already, can be used for monopile as well as jacket piles, and is proven. We have now installed more than on the Greater Changhua field in Taiwan more than 339 piles, and currently it's used on the monopile project Yunlin in Taiwan. So all in all, we have now installed a significant amount of piles and reached over 2.5 million blows with that solution. So going into the details, again, we are talking about underwater noise reduction, hence we are talking about sustainability for the market, to sustainability of the installation to protect the environment. When we see the blue and the green curve, this is the original force character of the hammer, and that has been changed by the modification of the MNAU into the red force character. The diagram we can see here is a force time diagram, and the energy which is transferred underneath the red graph is transmitted over a longer period of time, and by reducing that peak value we reduce the underwater noise. Going now one step further and seeing the sound pressure, or rather the sound pressure diagram underneath, we can see, and this is a very important point here, the values achieved, simulated achieved with this monopile. Very important when we talk about the force character and the interaction of underwater noise reduction technologies. This is all highly dependent on several parameters. So it can never be given a standard value how much a specific technology can reduce the underwater noise, as it is soil dependent, it's very high dependent on the geometry of the specific foundation or the specific pile, further the water depth, and obviously the hammer energy plays a major role. In this specific example here, our simulation has shown that a noise reduction of 9 to 11 decibel can be achieved. This is a simulation we are doing in-house to have a general understanding and to compare our hammer without and with noise reduction unit. But in general, we support an independent noise simulation by third parties and do support them. I will come to that later about cooperation. Now, leaving the field of the primary noise reduction system, the MNIU, we treat that as a primary system because we reduce the noise before it's given into the water. The other side of underwater noise reduction is for us the secondary system, and this is an example of a pre-piling template we built together with our sister companies. This pre-piling template has an integrated small bubble curtain, and this is the reason why we treat that as a secondary system, because the bubble curtain do reduce the energy, the noise, once it's in the water. This technology has been very successfully used during the installation of Wikinger 2016 in Germany. And look, in practice like this one here, when we see the complete construction site, it was obviously requested to have a double big bubble curtain around the construction site, but in the red circle we can see that the hammer in the center installing the pile is, or basically that the pile is surrounded by a small bubble curtain, which is so-called then the near-field noise reduction system. Leaving now the area of underwater noise reduction, we have identified the additional part. It's operational optimization. The optimization we have done here is that all our power packs operated in the renewable arena are equipped and outfitted with biodegradable oil. Further, all power packs which are nowadays ordered are sufficient to achieve the exhaust regulation stage 4 in China and stage 5 in Europe. The next topic is a topic we are following with our clients, with the T&I contractors, as well as with our supply chain. Those power packs at the moment are diesel driven, standard car diesel, and the provision of that specific diesel on the vessels is providing issues. Further, most of the vessels are able to provide electricity for the backdeck services. So together with our supplier, we developed a fully electrical power pack. This is design-wise available. We are currently in the investigation stage with our client to build those units. It obviously needs to be prior proven whether those installation vessels of the future are able to provide that significant amount of electricity to operate those power packs. To those ones who are aware of that, average consumption during pile driving, one of the power packs requires 2 megawatts. So in all, we require the provision of 4 megawatt to operate our power packs and have sufficient hydraulic oil flow to operate the hammer. 4 megawatt is a significant amount of electricity, but on the other hand, we believe that it's a good step forward to get rid of the diesel engines on the installation vessels, which, or not yet, but soon, could be CO2 footprint neutral, like Van Oort with a new vessel. And for those kind of vessels, we obviously would not like to jeopardize the CO2 footprint with a diesel engine driven power pack. For that one, we want to continue in the future with electrical power pack. Coming now to the cooperation, the sustainable is one thing what we can optimize with our equipment, which is constantly updated. But on the other hand, we believe that sustainability is somehow as well necessary to see how optimization can be achieved together. And the first example I would like to give is the cooperation with the company called Novicus out of Hamburg. With Novicus together, Novicus is basically performing and providing underwater noise acoustics simulations. This goes into the area of sustainability because the underwater noise simulation provides the developer with prior setup and selection of primary and secondary noise reduction system. And to make this simulation as sufficient as possible, we provide those simulation companies the step files of our hammer and all input parameter to simulate the impact of a hydraulic hammer on a specific project. So after choosing hammer size, hammer energy, and installation equipment, means pile diameter and angle configuration, Novicus is able to simulate our hammer and the operation of our hammer in this specific project setup. As we can see here, the green represents the water area, the blue is the soil area, and you can see pretty good, going now from the left picture to the right, that by giving one initial one blow onto the pile, that the noise value / the energy is traveling in gray representative here all the way down into the soil. It's in the first line protected by the eliminated by a near-field noise reduction system, but a certain percentage is tunneling the near-field noise mitigation system and is coming out of the soil again and is going into the water, which is then reduced by the second gray column, the far-field noise reduction system, in this case a big bubble curtain. How to set up the big bubble curtain, what kind of near-field noise mitigation system, and how much our MNLU can affect the underwater noise strategy is then part of the developer and this independent third party like Novicus to simulate and to choose the right noise mitigation system for the project. The next cooperation we are doing is that we, in this case, supported Van Oort. We have installed together with Van Oort the research project Borsele 5 in Dutch waters. In this case, Van Oort have installed the so-called slip joint monopile. The slip joint shall be for the future an alternative for the L-flange connection, but the requirement was to drive the slip joint monopile, which is conical at the upper part, what you can see on the first screenshot from the video I have added here, until all the way up to 5 meters underneath the water surface. This sounds pretty easy. Nonetheless, it requires adjustment on the hammer, and we, together with Van Oort, developed a solution that the monopile, in this case, can be driven all the way up until 5 meters underneath water surface. The source of this video and the site, the homepage of Van Oort, I have added to this presentation slide, and you can give yourself an overview. It's really it was an interesting research project and certainly provides some insights in this alternative monopile transition piece connection. The last one I would like to mention is a cooperation we are following with the company Cape Holland. Cape Holland is one of the vibratory hammer providers and the one who provided a monopile vibratory tool successfully to the market. The cooperation between Menk and Cape is long-lasting because we believe that the combination of the vibratory tool for appending and placing the monopile and driving the initial meter, and thereafter using the impact hammer to reach the final penetration and to guarantee the loading capacity, the bearing capacity on the pile, is a very sufficient technology or combination of technologies which we have used several times in oil and gas already. Just at the moment we have a project ongoing in Mexico where the combination of both technologies are currently used. The process can be seen here, and I think this is something which is known to the market as well. The vibratory hammer can be used as an appending tool, and the monopile can be placed on the seafloor. The initial driving with a vibratory hammer is then until to a certain depth able to correct. So what inclination and verticality, no, what inclination can be corrected. So now I have it, inclination can be corrected. So the cape monopile vibratory hammer has an inclination measurement tool integrated, and once a pile is self-stable and correctly orientated, the final driving will be done with an impact hammer. And this is actually applicable for monopile piles, or possible for monopiles like on this slide, or even for submerged unit. The cape as well as the Menk unit can be used submerged for jacket piling and has been proven several times in practice. To summarize, I would highlight once more that the very innovative technology we provided to the market, the MNIU, is now ready for usage and has been proven in practice. The secondary noise reduction system, the small bubble curtain, is certainly something project specific, which needs to be developed. Then the operational setup, that we updated our hydraulic power pack unit. And the fourth column is representing the cooperation that we want to enable third parties to give an independent view on the underwater noise simulation for a Menk hammer. And lastly, the combination of a vibratory hammer for initial driving and final penetration driving. Thank you very much for your attention, and I look forward to answer questions.